Hi everyone, my name is Ke. I'm a final year PhD candidate in the CSE department at UC San Diego. This video is a teaching demo for the topic Applications of Supervised Machine Learning. In this video, we are going to dive deep into an exciting aspect of artificial intelligence, which is supervised machine learning. It's a technology that is a part of our everyday lives, helping in making decisions, predictions, and improving outcomes across various domains. Here is today's outline. First, we will briefly review what supervised machine learning is and introduce the key concepts of supervised machine learning. Then, we will categorize supervised machine learning into two different types of problems, including regression and classification problems. We will further discuss their potential applications with different input formats, including text, audio, vision, and other sensory data. A simplified explanation of machine learning is to find a function from data that can map the input to the output. As you can see in these two examples, the speech recognition machine learning model maps the speech signals to the English text, "How are you?" The image recognition machine learning model maps the image to the cat category. Supervised machine learning is a specific type of machine learning. In this case, we are given a training dataset that contains training data and their designed outputs or labels. Our goal is to find a function that uses the input to generate the output by leveraging the training dataset. You can imagine that we are given many questions and answers pairs. For example, we have many images and we have the answer to whether this image contains a cat. Supervised machine learning figures out a way to answer future questions so that for any image in the world, it can identify whether there is a cat in the image. More formally, we are given a dataset D with n pairs of xi and yi, where xi is the input of the data and yi is the output of the data. We aim to learn a function f that can predict the y given x. The idea is that we can use the training dataset to evaluate the goodness of each function f, and then we can find which function is the best function to map input to output generally. We will finally use the best function as the supervised machine learning model. Let's use a specific example, handwritten digital recognition, to understand these concepts of supervised machine learning. As you can see, we have a training dataset with many handwritten digital images representing 0 to 9, and we already have the answer or label of each image. Therefore, we can try to evaluate the goodness of each function, for example f1, f2, f3, here to see which one can achieve the highest accuracy. Finally, we can determine which one will be the supervised machine learning model that we can use for the future handwritten digital classification problems. This process is similar to how we learn the digitals in our childhood. Teachers or your parents will always show a lot of digital images to us so that we can finally remember and know this kind of digitals. In the following course, we will mainly focus on how to design, train, and evaluate machine learning models. But today, you can simply consider the supervised machine learning models as the black box. Instead, we will introduce the input and output of supervised machine learning models and use them to categorize the type and application of these models. Let's first use the output Y to categorize the type of the models. If output Y is discrete class label, we call this problem classification problem. For example, the handwritten digital recognition problem is a classification problem because the output of this problem only has 10 different classes from 0 to 9. In comparison, when the output is a continuous value, we call it a regression problem. For example, when a task is to predict the PM 2.5 of tomorrow using today's PM 2.5, temperature, and concentration of O3, this will become a regression problem because the output PM 2.5 of tomorrow is a continuous value. I also want to let you know that even the input of the problem is exactly the same. It can either be a regression or classification problem, depending on the output of the problem. As you can see in these two examples, when you ask what's the temperature going to be tomorrow, this will be a regression problem because the temperature will be a continuous value. However, when you ask will it be cold or hot tomorrow, this turns to be a classification problem because the answer will be discrete, either cold or hot. These two problems are two fundamental problems for supervised machine learning. They can be widely applied to so many applications in our daily lives when we are taking different information and modalities as the input of the models, including the numbers, text, audio, visual, and even other sensory data. Let's first dive deep into the classification problem. The simplest classification problem is a binary classification, which means the output Y only has two targeted classes, typically will be yes and no. For example, email spam filtering takes the email as the input and to classify whether the email is spam or not. Cancer diagnostics take the medical image as the input and to determine whether the patient has the cancer or not. When the output has more than two classes, we call it multi-class classification. For example, Gmail not only classifies whether the email is a spam or not, but also categorize the email to social, updates, forms, and promotions. Then it needs to formulate the problem into a multi-class classification. Same as the medical image classification problem, if we want to use it to classify different diseases, it will be a multi-class classification. Another potential is that each input X can even belong to multiple classes Y simultaneously. We call this problem multi-label classification problem because each input can belong to multiple labels. For example, when we do the email categorization task, the email can belong to both personal and urgent categories. Compared to multi-class classification, multi-label classification will be more general typically. As you can see in this figure, multi-class classification can solve the problem that the image contains only one animal, say the dog. However, when there are two animals in the image, like there is both dog and a cat, it is hard for multi-class classification to determine whether this can be classified as a dog image or a cat image. when we formulate the problem into a multi-label classification, we can easily classify it as both dog and cat images. To sum up, we use two example applications, the email and the image classifications, to introduce different types of classification problems. With the same input, we can even formulate the problems into different classification tasks, including the binary classifications, multi-class classifications, and multi-label classifications. Typically, for the real-world machine learning model design, we need to formulate classification problems based on both the usage scenarios and the data and label of training datasets. Let's do a quick practice to use these concepts by taking the input X as the audio recording. When we want to classify whether the audio recording contains the voice, what's the potential classification problem? Yes, it will be a binary classification as the output is either yes or no. We call this voice activity detection task. When we want to identify who is speaking, what's the potential classification problem? If there is no constraint, this can be a multi-label classification problem, as two speakers may speak at the same time. However, typically, we will assume there is only one speaker. This then can become a multi-class classification problem. We call this problem speaker diarization problem, as it can distinguish the speech from different speakers, which can be used for many speech processing applications. In this example, we identify the speech signals of different speakers, which can be useful for some applications like automatic captions generation. As we mentioned earlier, when output y is a continuous value, we call them regression problems. Regression is widely used for tasks like predictive modeling, forecasting, analysis, and marketing, etc. The applications are sales, demand, stock, price, weather, because people like to use continuous values to describe them. For example, we can predict the stock price for the next day, or we can analyze the marketing sales in the next month. This will all be regression problem. Same as the classification problem, if the output y has only one continuous value, it will be a single target regression. But when the output y has multiple target variables, we also consider it as a multi-target regression problem. For example, when we do the weather and air quality prediction, because air quality, temperature, and humidity interfere with each other, we will have to model it as a multi-target regression problem to regress these factors simultaneously for better performance. Let's have a quick sum up. Today, we introduced the applications of supervised machine learning. The two types of problems, including classification and regressions, are two fundamental supervised machine learning methods. For a specific application, we need to consider the data and labels of training datasets and the usage scenarios to determine which one will be the most suitable model. There are also more sophisticated applications of supervised machine learning. A typical example is that the input X and output Y are all sequence rather than a single value. Like the texture data, speech signals, video, they are typically sequence data. We will design sequence model to solve these problems. Let's use language processing as an example, as they are all sequence data. If you want to achieve machine language translation from English to Chinese, we will use the sequence model. Here, we translate the sentence, sequence models are super powerful to the Chinese language. Another example is the chatbot, like the famous ChatGPT. It can answer any of your questions. For example, when I ask it, can you summarize what supervised machine learning is? It will answer, supervised machine learning is a method where models learn from labeled training data to make prediction or decisions. One of the challenges is that both the length of input and output sequence are variable in this kind of sequence models. We will also discuss how to formulate this problem using supervised machine learning and how we train such kinds of models using neural network in this course later. That's it for my teaching demo. Thank you. If you have any question, please feel free to contact me via email.